Welcome to the vastness of space. Stretch your imagination beyond the blue sky, past the shimmering stars, into the immense dark tapestry that cradles our solar system. Have you ever wondered how everything around us, the sun blazing overhead, the planets that circle it, the moons, the asteroids, even the dust in the air, all came into existence? It's a journey that spans billions of years, an epic transformation from nothing but a silent, shapeless cloud into the vibrant cosmic neighborhood we call home. Today, let's unravel the true origin story of our solar system. Travel back in time, to about 4.6 billion years ago. Our sun, the planets, and the Earth beneath your feet did not yet exist. In their place, drifting in a quiet corner of the Milky Way galaxy, was a vast molecular cloud. This cloud, known as the solar nebula, was composed mostly of hydrogen and helium, the simplest and oldest elements in the universe. Mixed within were traces of heavier elements, forged in the fiery hearts of earlier generations of stars and scattered across the cosmos by colossal supernova explosions. For millions of years, this ancient cloud floated undisturbed. But then, something changed. Perhaps, in the distance, a massive star reached the end of its life and exploded in a spectacular supernova. The resulting shockwaves rippled through the galaxy, compressing the gas and dust of the solar nebula. Gravity, the quiet architect of the universe, took over. Under its relentless pull, the cloud began to collapse inward upon itself. As the nebula contracted, it started to spin. Like a figure skater pulling in their arms to spin faster, the cloud's rotation increased. It flattened into a vast, spinning disk, a cosmic whirlpool of material, glowing faintly from the heat of compression. At the center of this disk, gravity drew most of the mass together, forming a dense, hot core. Over thousands of years, the pressure and temperature within this core soared higher and higher. Eventually, temperatures reached about 10 million degrees Celsius. At this critical threshold, hydrogen atoms began to fuse into helium, releasing bursts of energy. With this ignition of nuclear fusion, a new star was born, our sun. Its radiance swept outward, illuminating the darkness, and its powerful solar wind began to shape the evolving solar system. Encircling the newborn sun was a flattened, rotating protoplanetary disk, a swirling mixture of gas, dust, ice, and rocky debris. It was within this disk that the planets would form. The process began at the tiniest scale, microscopic particles bumping into each other, sticking together through static electricity and other forces. Over time, these dust grains grew into larger and larger clumps, pebbles, then boulders, and eventually, planetesimals, rocky bodies tens to hundreds of kilometers wide. Once planetesimals formed, gravity became the dominant force. These bodies collided, merged, and gathered more material from the surrounding disk, growing into protoplanets. In some areas, several protoplanets jostled for dominance, while in others, a single body swept up most of the available debris. But not all parts of this disk were the same. Closer to the sun, the intense heat prevented volatile materials like water, methane, and ammonia from condensing. Only metals and rocky minerals could survive these scorching conditions. That's why Mercury, Venus, Earth, and Mars, the so-called terrestrial planets, are small, dense, and rocky. Farther from the sun, beyond a region known as the frost line, temperatures were low enough for ices to form and persist. Here, planetesimals could accumulate not just rock and metal, but also water ice and frozen gases. These ingredients allowed the outer planets to grow much larger, as they could capture and hold onto hydrogen and helium, the lightest and most abundant elements in the disk. Jupiter and Saturn became gas giants, their immense gravity enabling them to grow rapidly and dominate their region. Even farther out, Uranus and Neptune formed as ice giants, their compositions rich in water, ammonia, and methane ices. Jupiter, the mightiest planet of them all, played a critical role in shaping the entire solar system. Its massive gravity influenced the orbits of countless smaller bodies, redirecting planetesimals and even ejecting some entirely from the system. Jupiter's presence may have prevented the formation of a planet between itself and Mars. Instead, the leftover debris forms the asteroid belt, a scattered collection of rocky remnants that never coalesced into a world of their own. The early solar system was a place of incredible violence. Protoplanets collided, sometimes merging, sometimes shattering into fragments. One particularly dramatic collision changed Earth forever. A Mars-sized body, known as Theia, slammed into the young Earth. The impact was so immense that a portion of Earth's mantle was blasted into orbit, eventually gathering together to become our moon. This cataclysmic event also tilted Earth's axis, giving rise to the seasons we experience today. As Earth and its neighbors recovered from these impacts, the outer solar system continued its own tumultuous development. The giant planets collected rings and moons, many of which may be captured remnants of earlier collisions or migrating planetesimals. Some evidence even suggests that the solar system once harbored a fifth giant planet, which was ejected into interstellar space during a period of gravitational chaos. For hundreds of millions of years after the planets formed, the inner solar system underwent a barrage of impacts from asteroids and comets. This epoch, known as the Late Heavy Bombardment, left behind the craters we still see on the Moon, Mercury, and Mars. Some of these incoming objects may have delivered water and organic molecules to the early Earth, providing the essential ingredients for life. Gradually, the chaos subsided. Most of the debris was cleared away or swept up by the growing planets. The major worlds settled into their stable orbits. The Sun reached a peaceful, mature phase, shining steadily at the center of its planetary family. From a silent, ancient cloud of dust and gas, the solar system had emerged, a harmonious arrangement of planets, moons, and smaller bodies, each with its own story written in stone and ice. Earth, unique among them, became a cradle for life, eventually giving rise to beings who could look up and ponder their origins. The formation of our solar system is a tale of gravity, collisions, creation, and survival, a cosmic drama billions of years in the making. Every planet, every moon, every asteroid carries the memory of that ancient transformation, some stories still unfolding, others forever lost in the depths of time. Yet, it all began with a quiet cloud of dust. From that silence came the Sun, the Earth, and us, standing here, wondering how it all happened. So keep asking questions, keep looking up. Remember, you are part of a system that took 4.6 billion years to build, a miraculous product of cosmic history, forever connected to the stars.